Hello everyone, my name is Rémy. I work with the EveStaker community, and today I'm going to show you how you can migrate to a larger disk if you are an Ethereum validator. So let's jump right away into it. We will check out first one of my guide that I wrote about this, which I'm going to also link in the description below, where you can get all this information and even more on how to do this. Today I'm going to be using a test machine that I just synced on mainnet as well. So we will show you guys how to do this migration and how you can check on your current disk space and what are the potential alternatives to migrating to a larger disk. So let's get started with my machine here. So I'm connected remotely on this mini PC, and you can see here this is on Ubuntu. So one of the first thing that you can use to check on your disk space, first of all, is df-h, which is going to show you all your file system. And in this example here, you can see that the main file system is this one here, dev /mapper /ubuntu something. It's currently using almost 1 terabyte of disk space, and it still has a long way to go before it's fully used. It's only using 56% of the disk right now. This is running Geth with PBSS and Lighthouse, which are two great clients, especially Geth on the execution side for disk space usage. Another command that you can run to check on your disk space, which I love, is a tool called ncdu. It's a tool that you can use to explore which of your directories are using the most space. So in this case, since this is like a dedicated device running on mainnet, the main directories that are going to be using space on disk machines are going to be the ones for Geth and its database and for Lighthouse. So let's just run the command ncdu -x-q and then / to check out from the root directory. And you can see this is like an example of what you will get when you run this tool. You can interactively browse into the different subdirectories. So let's go and check out on the var and lib subdirectory. I know this is where I configured my clients to store their data. And you can see in this example on a fully synced node, a recent fully synced node using Geth and Lighthouse, that like Geth is using about 924.7 gigabyte of disk space, and Lighthouse almost like 40 gigabyte of disk space. So this is what you can expect on February 2024. As you know, as you keep running these nodes, more transactions and more states are being stored on the blockchain, and those states needs to be stored somewhere, and in many cases the node operators are the ones storing these states, so it grows over time, and like there's different ways to manage this like this growth of space. But these are some of the like commands that you can run to check on your disk space. Another one that I like is fdisk. I believe if I check here, it's with -l. So fdisk with -l will give you a list of your disk and their partition. So in this instances here, I'm using a Samsung SSD 980, 2 terabyte, and you can see it's currently using like 3 partitions, and those ones were also shown with the df command. And you can see like the main partition is this one here, the NVMe 0 and 1 P3, which is almost like 2 terabyte big. But the other ones are like for the boot system. So like this is using like the default option when I installed the Ubuntu 20.04. So those are the simple like commands that you can run to check on your disk space. Before trying to migrate to a larger disk, you should know like there's a bunch of different options that you can take. Pruning is one of them. So many clients will accumulate unneeded data over time, and pruning is like a process that you can use to just remove this junk over time. Some clients have a manual pruning process. Other like Nethermind have options to do this automatically. So this is a great way to manage your disk usage. Updating and resyncing from scratch is a great option for some client. As client improve on their strategy to store their data, they often have like new ways to use databases, and then if you resync from scratch, you can gain some improvement on disk usage. There's various configurations that you can use. Like a big one, for instance, is the path-based storage scheme for PBS. For GEF. So it's PBSS. It's like a recent way, or a recent option that GEF added to use less disk space. If you want to start using this configuration option, you'll have to resync from scratch, but it gives you some very important disk usage improvements. And like various clients will have different options, so you should consult your client documentation about this. Migrating to a different client can be an option. As of today, GEF with PBSS is like one of the most disk efficient way to store the execution data for your node. But you should also know that GEF is currently like a majority client on the execution layer. And there's a few cons that you should be aware, like it poses a significant risk to your own stake if you're using the node for staking. And it's also not that healthy for the whole network. So there's pros and cons that you will have to think about if you want to go that route. Using multiple disks is another option. Instead of like migrating to a larger disk, if your system was configured in a way to enable extending your partition easily, such as with LVM, it could be an option. Also, if you have enough room in your machine. Many mini PCs or NOCs don't have like that many SSD slot, for instance, so it might be harder if that's those kinds of machines that you're using, but it can be a very interesting option as well. Adding monitoring and alerting for your disk usage is also a good practice, so just so you know, this is a good way to do it. So let's switch to migrating to a larger disk and actually do one for this test machine that I'm using right now. The general idea to migrate to a larger disk is quite simple. You stop your known machine, you plug both disks into the same machine. It could be the machine you're using for staking, or it could be another one. You boot into a live OS or a tool to perform the copy. You extend your volumes, your partitions, and your file system on the larger disk in order to be able to use the full capacity, and then you plug the larger disk back into your staking or node machine, and you restart it. That's pretty much it, and we'll show you how to do it. To start, I will prepare a bootable USB disk to boot on with the tools that I need to perform the disk clone or the disk copy. In this case, I'm going to be using Clonezilla. Clonezilla is a great tool to do this, and I'm going to be using Rufus to create the bootable USB. Just before I'm gonna show you the Clonezilla website. So you will need to download the live version of Clonezilla. So this is their website currently. I suggest you select the stable version, and then in here, I suggest you download the ISO file type. Make sure to keep the CPU architecture to AMD 64, and then click download to download this. For Rufus, if you're on Windows, this is a great tool to create bootable USB drives. It's very simple to use. You can download various versions down here, and I'm gonna show you how to. I'm back here in my download folders with all the tools that I need to create a bootable USB stick. I'll start Rufus. I've already plugged the USB stick into my machine here, so I can select it here. If you have multiple, they will show here. You have to select the ISO image, so let me just select it here. I'll select Clonezilla Live. And then all I have to do now is click start. I'll give this a Clonezilla label, just so I know when I plug this USB stick. You can use the recommended option here. Nothing special about that. And then you'll just have to wait until this is all done. And we're done with creating the bootable USB sticks. I can just click close here. So my machine is still running, my staking machine here. So I'll just stop the machine, plug both SSD on that machine. I'll plug the USB stick as well and come back to show you how I can boot on the USB stick. We're back here and I'm rebooting my machine. I'm holding escape in order to access the boot menu. I'm gonna go into the boot here option, and you can see that I plugged in like my USB adapter in my USB stick. The USB adapter is simply for me to connect my larger disk. This mini PC only has like one slot for an NVMe SSD, so I bought like this. Let me show you here. This one here. It's not showing great on screen here, but this is like a USB adapter type C for NVMe disk, so I can add the new disk on that machine. And I bought this new disk here, a 4 terabyte disk, so I can do the cloning and show you guys how this is performed. But in order to boot on this machine, I will be using the USB stick here, which is this boot device here. It's the SanDisk disk that's only like 16 gigabyte big. So let me click enter, save configuration to, and since this is loading from a USB stick, it might take just a few seconds for the whole operating system to load. So we'll just wait. Now I can select my language. Let's keep it in English. Keyboard layout is fine. We will start the Clonezilla text-based user interface here. If you are very advanced, you can use the command line prompt, but since this is more of a beginner, guys, let's use the text-based user interface here. In order to clone from a disk to another disk, I will select the device to device mode here. Clonezilla is currently looking for all the disks that are connected to this machine, and eventually I'll be able to keep going. Now I'll select the beginner mode here. If you're truly expert, if you know what you're doing, there's a bunch of advanced options that you can select here. I won't go into any of these options, but beginner should work for most people. I want to copy a full disk, like I want to do a full disk clone. So the first option here is the one that I have to select. At this step, I have to select the source disk. So if you look at the description, like it's kind of hard to see, but like the source disk is my Samsung SSD 980, 2 terabytes. So I know that's like the smaller disk that I have, and like the bigger one is gonna be like the 4000 gigabyte disk. So I can select the first one as the source one, and I'll be prompted to select the target one here. So I want to select the bigger one to migrate from the smaller one to the bigger one. At this step, you can select just to skip checking repairing the source file system. This step is quite important here. If you want to have Clonezilla, just expand the partitions on the target machine. Not the target machine, but the target disk. I suggest you select the dash K1 option here, which will simply create partition tables that are proportional to the new disk size. So I don't know if you remember when we checked on the partitions that I had on my original disk. There's like 3 ones, and the main one was like almost 2 terabyte large. So this will simply expand that partition automatically to use like double the amount of space, right? Which is exactly what we want here. And as a last option here, you can select what you want Clonezilla to do when it's done with all of its tasks. So like you can select shut down, it'll just shut the machine down, or you can select to prompt you to ask you like what you want to do when all of this is finished. So let me just select this option here so I can show you the full progress of the tool. I'll be prompted to confirm a bunch of stuff. So let me just do that, and eventually we will be able to show you the progress of dialog. All right, so Clonezilla started to clone the different partition. It's already done with the first one since that was like a smaller one. This is the second partition, which is only 2 gigabyte large, which should be like very fast. Now we are going to start on the third one, which is like the main and largest one, which is going to take a few minutes or hours. You can see that my transfer rate at this point is around 25 gigabyte per minute, and Clonezilla will show you an estimated remaining time. As of now, you can see it's still fluctuating, but as of now, it's showing that it'll take around 1 hour and 35 minutes. We'll come back once this is like closer towards the end of the disk clone.
A few moments later.
Hey, we are back and we are mostly done with the cloning process. As you can see, it almost took 2 hours to clone this 2 terabyte disk onto a 4 terabyte one. If you remember, we told Clonezilla to ask us what to do next. I believe it's simply doing a few checkup now, and we will simply ask Clonezilla to shut down the system. All right, everything's mostly done. Let us continue here, and we will power off the system. Now I will switch the disk. As you remember, this is my mini PC, and I will simply remove the 2 terabyte disk and put the 4 terabyte one. Hey, I'm back in. My machine is mostly working, so I switched the smaller SSD. I put the bigger one or the larger one back into the machine, and I rebooted, and everything is working fine. Now there's something that I'm missing, right? So if I check on the current disk space usage, you can see that I still only have like 1.8 terabyte of available space, even though I'm now using my bigger disk, and I can confirm this by just calling fdisk-l, and you'll see now that I'm running on this new 4 terabyte SSD. The partition is good, like it was expanded. However, since I'm using LVM, I will need to perform a few tasks to expand the LVM structure. So LVM uses physical groups, physical volumes, and logical volumes. And in order to be able to use the additional space created by this new SSD, I will have to expand my physical volume, my logical volume, and the underlying file system. And there's two easy commands that you can use, which are pv resize and lv extend. But first I need to find out the path of those physical volumes and logical volumes. And there's a quick command, it's this one here, which you can call to find out. So let's call this one. So my physical volume is path is this one, and the logical volume path is this one, right? So let's start with the pv resize to resize my physical volume. There you go. And in order to extend my logical volume, I have to call this command here. So you can simply copy and paste the command with the logical volume path. So let me go ahead and copy that path here. There you go. Should be very quick. And then once you're done, you can confirm that my available disk space or disk size on my main volume or file system here went up to 4 terabyte or so, like depending on how you format it, right? And I'm pretty much done. Like my client restarted automatically, everything's working as intended, and now I have more space to handle these additional states that needs to be stored. So what else should I be doing next? What is there remaining here? Nothing much really. I could decide to wipe clean my other smaller SSDI, especially if you're a staking node and you still have your validator keys on that other smaller disk, which is right over here. It's this small disk here. You should strongly consider wiping this disk simply to make sure you're not running both of your keys at the same time, right? For instance, if you were to plug this one in a new disk and boot on it by accident, running the same validator keys twice at the same time might cause a slashing event, in which case you would lose some money, right? So thanks for watching. I hope you learned something, and I'll see you again in a other video. Bye bye.